students, welcome to Earth educational channel. So in the previous 4 videos we have looked on the first chapter, that is number system. Today we are going to start the second chapter of NCERT in class 9 sec 2, that is polynomials. Okay, before we dive into polynomials, we want to look into two things first. Okay, before we want to dive into polynomials, we want to look into two things. One is operations. First is operations. What are operation? Operation is addition, okay, subtraction, multiplication, or division. Okay, or division. These are the basic. These four are the basic mathematical operations. Mathematical operations. Understood? Operations are performed over. These operations we perform either on numbers or algebraic expressions. Operations are either performed over numbers or algebraic expressions. Understood? So the numbers part, you know this is 2, this is plus 4, this is one number, you are performing the operations of addition. You are getting the result 6. One another form is algebraic expression. See, I'll talk more about algebraic expression. Just I'm giving you an example first. Okay, 2x square is one algebraic expression. We are performing the addition with another algebraic expression, that is 4x, with another algebraic expression, that is 2, equals to 0. This is a polynomial. Okay, this is a polynomial. I will talk more about algebraic expressions and polynomial in detail. You take this as you have seen these examples. This is a quadratic expression. Okay, so this equation is also a polynomial. So what is algebraic expression? This individual 2x square is an algebraic expression. This 4x is an algebraic expression. 2 is an algebraic expression. We are performing the operation of addition over these algebraic expressions. So operations are either performed over numbers or algebraic expressions. Okay, you have seen some of the algebraic identities. You have already learnt about it in class 7th. Algebraic identities. What are some of the examples of algebraic identities? X plus y whole square equals to, you have learnt about it, x square plus y square plus 2xy. You have learnt about it. This formula you have learnt, x minus y whole square equals to x square plus y square minus 2xy. You have learnt about it. This in the previous chapter only I have told about these expressions. This expression also we have heavily used in the previous chapter in number systems. X square minus y square is x plus y into x minus y. Understood? These three are the algebraic identities. Okay, so you have learned about this. So what are identities and everything we will cover again. In this chapter only we will cover, but we will cover in other sections, not in the first section. I'm only giving a glance. See, first part is operations. Understood? Operations, polynomial involves two things. One is operations, the other is algebraic expressions. Polynomial involves only two things, that is operations and algebraic expressions. So what is a polynomial then? Polynomial is one type of algebraic expression. Okay, polynomial is one type of algebraic expression involving operations like addition, subtraction, multiplication and division. I've already said this. This is a polynomial. This is a polynomial. See what 2x square is an algebraic expression. In itself. Understood? Similarly, 4x is also an algebraic expression. Understood? 2 is also an algebraic expression. Let me write like this. See, let me write it here. See, 2x square we have written, then we have given a plus sign, then 4x we have written, then plus, then 2 equals to 0 we have written. See, okay, so this whole is a, I am telling you, this whole is a polynomial. 2x square in itself is an algebraic expression. Understood? 2x square in itself is an algebraic expression. 4x is also an algebraic expression, and so is 2. Okay, this do means the above part is repeating. Understood? Means 2x square is an algebraic expression, 4x is also an algebraic expression, 2 is also an algebraic expression. So we are performing what? Performing the operation of addition. Okay, this thing is a polynomial. This polynomial is one type of algebraic expression involving operations like addition, subtraction, multiplication and division. It involves algebraic expression, it involves operations also. Okay, then we are going to look into the second part, that is polynomials in one variable. Okay, so what is polynomials in one variable? See, first we'll discuss about we'll discuss what is algebraic expression first. Algebraic expression. Understood? What is algebraic expression? Algebraic expression consists of two parts. Okay. There are two parts to an algebraic expression. One is what? One is variable. The other is constant. These two terms I have written. One is an algebraic expression consists of two parts. That is, one is variable, one is constant. So what is a variable and what is a constant? See, in the previous example, I wrote that 2x square is an algebraic expression. Okay, 2x square is an algebraic expression I wrote. So we'll dissect this. One is 2, one part is 2. Okay, one part is x square. Okay, one is 2, one is x square. See, the value of 2, it is never going to change. It is never going to change. over equations. Okay, see this equation, in this equation 2's value is never going to change. See 2 in this expression, the value of 2 will never will never change. The value of x may change, because if I change, instead of 0 if I write 2 here, the value of x will change, but the value of 2 will never change. Understood? We are understanding. The value of 2 will never change in this algebraic expression. It is a constant. So it's a what? It's a constant. Value, its value, x square's value, its value will change with change in parameters. We change in parameters or equations. Okay. If I change the parameter, instead of 0, if I write 2, 3 something, okay, if I solve this thing, if instead of 0, if I write here 2, if I write here 3, if I write here 4, the value of x is going to change, but the value of 2 will never change. Okay, so this part is the constant part. So this part is the variable part. Okay, I will make you understand more properly in giving one example. Okay, I will make so variable, you are seeing here that variable's value will change. We change in parameters or equations, but constant's value will never change. Okay, so here you are seeing that variable, that constant is written as a number, and variable is written as a symbol of x we are giving. Okay, but that is never the case. The algebraic expressions can be of the form algebraic expressions form is equals to constant into a variable. Okay, this is the means the form of algebraic expression. Algebraic expression form is constant into a variable. You multiply a constant with a variable. Okay, understanding? Now in polynomial of one variable, this variable, it contains only one. See, this is self-explanatory actually. This, in polynomial of one variable, it contains only one, means in the algebraic expression, I'm going to write it like this: in the whole algebraic expression, it contains only one variable. Okay, it contains only one variable. What do you mean by this? See this example: 2x square plus 4x plus 2. This example that I had written. See, only variable present is here what? Only variable present here is x. It may be x square, x5 something, but the variable is only x. X value in this whole equation will remain the same. It may be x square, means 2 times you are multiplying x, 3 times you are multiplying x, that doesn't matter, but the value of x will remain the same in this equation. Okay, so this variable, only one variable, only x is there. Okay, only x variable is present here. So what is a variable first? See, a variable is denoted by a symbol that can take any value. See, in earlier classes you might have written, see, let's say x equals to something. So you want this variable thing to take any value. Constant will never take any value. It has a fixed value. But this variable can take any value. We use letters like x, y, z, etc. to denote variables. See, in the English alphabet, from the letter end, that x, y, z and all are used in variables, and in the starting end, that is a, b, c, okay, we use constants that are unknown. Be represented by letters such as A, B, C, etc. Understood? Variables are expressed by x, y, z mostly, and constants are written as in the form of A, B, C, etc. Understood? So let me write some examples of algebraic expressions. Some examples of algebraic expressions are 2x is one algebraic expression, 3x is an algebraic expression, minus x is an algebraic expression, minus x by 2 is an algebraic expression. If I use unknown constants, example of unknown constants. Okay, examples of unknown constants, if I use ax, bx square, understood, minus cx, these are unknown, minus dx, so these are unknown. In unknown format you can write. Here constants are also not known. The value of constants are not known. Understood? The value of constants are not known. So why, see, here I have written constant into variable, but here you are telling that, sir, the value of constants are not known itself. Then it can take any value if it is not known. Here in 2x we knew that the value of constant was 2. Okay, but here you are telling ax, the value of a we don't know. So how it is a constant? See, I am going to give you an example. Let me take a square. Okay, let me take a square. In this square, suppose the side is of length 4. Let me, this square OABC. Okay, OABC, let me take a square of side, let me take a square OABC of side length 4. Okay, so perimeter of the square will be how much? Perimeter of the square will be 4. See, perimeter is what? The length of all the sides. So 4 plus 4 plus 4 plus 4, that is 16. Understood? Now again take a square PQRS of side length 10. Okay, you are taking a square again P, Q, R and S of side length 10. Okay. Now the perimeter of the square, perimeter of the square will be what? This will be 10 plus 10 plus 10 plus 10, that is 40. So see, the what we are doing for perimeter we are multiplying the or adding the side length 4 times. So we can write perimeter of a square of side length x equals to what? 4x. See, from here you are clear, 4 is constant. For this equation, that perimeter will be given by 4x. 4 value is always constant, but x value, depending on the length of the side, the value of perimeter will change in this equation. Understanding? So 4 is a constant, x is a variable. Understanding? Similarly, area of a square, you know, area of a square is x square. That means 1 into x square. 1 is the constant, x square is the variable. You are getting my point? So this is the format of actually algebraic expression, that is constant into a variable. Okay. So what is the difference between a constant and a variable? I can write difference. Let me write it here. Difference between a constant and a variable. Then constant and a variable, you can write it as the values of a constant remains the same in a given problem or situation. Understood? But the value of a variable keeps changing. Okay. The values of a constant remains the same in a given problem or situation, but the value of a variable keeps changing. Suppose my situation is to find the perimeter of a square. The value of the constant is, means the equation is 4x, but the constant value 4 will always remain as 4. It will never become 3x or 2x or something. It will always become, the constant value will always be 4 only. But x will change. Depending on the length of the side, the x will change. Okay. So some of the examples of algebraic expressions, again, examples of such algebraic expressions. Some examples. Okay. Algebraic expressions. I have written, see here in these examples only x to the power 1, 2x, 3x, minus x by 2. But now you are seeing that x square is also an algebraic expression. So of that form you can add, it can be x square, it can be 4x, it can be x square plus 4x. The addition of both, it can be x square plus 4x plus 2 also. That is also an algebraic expression. It can be x cube plus 2x square plus 4x plus 8. Okay. So many algebraic expressions are there. This is an algebraic expression. This is an algebraic expression. This is also an algebraic. This is also an algebraic. These all are polynomials also. Okay. These all are polynomial also. Okay. So what we are reading here was polynomial in one variable. See, in these equations only x is there. Here only one variable x is present. where only one variable x is present. Okay, so if in an expression or equation, you can say, if in an expression or equation only one variable exists, it is called polynomial in one variable. Polynomial in one variable. See, this is important. Okay, when we call it a polynomial in one variable, only if in the expression or equation only one variable is present. This is one point. Second point also should satisfy the powers, or in the previous chapter we have read what we call powers as exponents. The exponents of variables should be whole numbers. This is a very important point. See, in exercise also, questions related to it is also there in the first exercise. See, if in an expression, when a polynomial is called a polynomial in one variable, okay, both should satisfy. And this is and, okay, this is and, both should satisfy. If in an expression only one variable exists, it is called a polynomial in one variable, and the powers or exponents of variables should of the variables, not of the variable, should be whole numbers. Okay, see here what I am telling you is, see here 2 square, here only one variable is there and the power is 2, so this is a whole number, so it is a what, polynomial in one variable. Here x square I am writing, variable is equals to 2, okay, exponent is not sorry variable is x, exponent equals to 2, a whole number, so a polynomial in one variable. Okay, let me write this example. This example is x cube plus 2x square plus 4x plus 8. Only variable is x. All exponents 3 is there, 2 is there, 1 is there. Here it means x into 8 into x ki power 0. If only 8 is written in an equation, it means 8 into x ki power 0. So 0 is also an exponent. So 3, 2, 1, 0 are all whole numbers. Okay, so they satisfy the conditions of polynomial in one variable. Understood? In this equation you are seeing that only x is here. Here also x, here also x, here also x is there. Understood? And what? And all the powers, all the exponents here, this is 3, this is 2, this is 1, this is 1, okay, this is 0. So 3, 2, 1, 0 are whole numbers. So both the conditions are matching. We need both the conditions to be true. Both the conditions are matching, so it is a polynomial in one variable. I am taking my time here because in the question 5 questions are there. I will not give you time. I will just write that. See, this is well, variable is x, exponent are whole numbers, so it is a polynomial in one variable. Okay, so these are the two conditions. It is very important. So that is a polynomial in one variable. Yeah. So what we can write is actually polynomials. Polynomials in one variable. Okay. This polynomial in one variable means what? One variable means only x is present as a variable. Only x is present as a variable, you can say x or y or z, anyone. Only that means only one variable is present. And polynomial means what does polynomial means? Different exponents in variable as base in the algebraic expression. Okay, in the previous example, see, these things only I have covered. See, in the previous example, the polynomials in one variable means what? Polynomial means different exponents are there in variable. Okay, in the algebraic expression, different variables are there which are whole numbers. Okay, different exponents which are whole numbers. Understood? Polynomial means in the algebraic expression, the variable is as the base. I've already told you, if you write A is the base, M is the exponent. In the previous videos also I have told you M is the exponent. Okay, so if you write x cube, means x is the variable, so x is the base, this 3, that is the exponent. Okay, so polynomial in one variable means only one variable is present, and in the expression the variable is the base and its exponents are whole numbers. Okay, so that is polynomial in one variable. Now this is C. Polynomials can be written, see, variable, if the variable is y, the variable is y, polynomial expression looks like this. Okay, here we are writing what? X cube plus 2x square plus 4x plus 8. So same thing in y, I will write y cube plus 4y plus y square plus y 8y plus 16, something like this. This is also a equation. Okay, so if we are writing the equation, y cube equals to 4y square plus 8y, 4y square plus 8y plus 16. Okay, this is an equation in y. This you can write as p of y. Here we denote the equation, the polynomial, as py. We denote polynomials as px, qy, rz, etc., where x, y and z are the variables. Okay, example, px equals to 2x square plus 4x plus 6 equals to 0. Understood? This is px. Qy, if I'm writing, you can write py also, there is no harm in that. P is the px is this. If I write py, no, it should be this. P means this expression, px you writing means the expression. If I write py, it should be 2y square plus 4y plus 6. Px means that whole expression is px. Understanding? This px means this whole expression is unique. Okay, to px. Qy I am writing, it can be x square plus 3x. No, sorry, x I am writing. Sorry. This will be y square plus 2y plus 3 equals to 0. Something like this. Rz is z plus 2. This can also be an expression. Okay, so if we want to express polynomials are expressed like this. Px, this expression is unique to px. If you write py, instead of x you have to write y only. but this equation will remain the same. Understood? So polynomials are denoted as such. Now polynomials has two parts actually. A polynomial has two parts. Okay, what are those two parts? Okay, one is term, the other is coefficient. Actually it is not two parts also, it is the same part. Okay, I will tell you. In a polynomial each individual expression of a polynomial, expression means algebraic expressions I am talking about. Okay, each individual polynomial expression of a polynomial is called a term. Okay, is called a term. Okay, is called a term. In this expression 3x square plus 4x plus 2, the terms are first term is 3x square, one term is 4x, third term is what? 2. These individual algebraic expressions, each individual algebraic expression in a polynomial is called term. You are getting it? Now each term of a polynomial has a coefficient. Each term of a polynomial has a what? Coefficient. Example, see 3x square plus 4x plus 2. So in the term 3x square, term is 3x square. In this term 3x square, coefficient is 3. In the term 4x, coefficient is 4. Okay, these part, the constants, coefficients are the constants. Coefficients are the constants multiplied to the variables in a term of a polynomial. Understood? In the term of a polynomial. You are getting it? Coefficients are the constants. In see here 3 terms are the 3x square, 4x and 2 is a coefficient. 2 is a coefficient here. 2 is a coefficient here. Understood? 2 is a coefficient here. The constants that are multiplied to variables in a term of a polynomial is called coefficient. See, this whole is a polynomial. First of all, this whole is a polynomial. Each individual algebraic expression, that is 3x square, 4x and 2 are the terms. Okay, inside the term there is a variable, there is a coefficient. X square, x is a variable. The constant that is multiplied to the variable is called the constant. Understood? So coefficient of what? This is coefficient of x square. Okay, this is coefficient of x. In this polynomial, the coefficient of x square is 3, coefficient of x is 4. This is also given in exercise. Okay, I'll not delve much into it. Coefficient of x square is 3. We have to find in an equation. If it is said to find the coefficient of x to the power 0. So what is the coefficient of x to the power 0? Okay, here it is 2. Simply 2 means 2 into x to the power 0. X to the power 0 is 1. So 2 into x to the power 0. So coefficient is 2. Coefficient of x square is 3. Coefficient of x is 4. Understood? Now, constant polynomial. Constant polynomial. Constant polynomials. What are constant polynomials? All integers are constant polynomials. All integers are constant polynomials. How? How all integers are constant polynomials? Okay. Example. Suppose we are writing 2 only. This 2 can be written as what? 2 into any variable, suppose x, to the power 0. This can be that is only 2 into 1 equals to 2 or not. So this 1 can be written as any variable to the power 0. So it is a constant. See, polynomial means a variable is involved, a constant is involved. Okay, that is what polynomial means. Here, instead of only 2, we are writing 2 into 1. Instead of 1, we are writing 2 into x to the power 0. This is a variable. This is a constant. So it's a polynomial. Okay, it's a polynomial. Constant variable, it's a polynomial. Okay, one more thing is this thing 0 is called zero polynomial. See, one property also I will tell you of zero polynomial later. In this section only I will tell you 0 is called zero polynomial. Actually it helps to identify the type of equation. Okay, so this property I will tell you of zero polynomial later in this section only. I will tell you when I talk about degree. Understood? So some examples I will tell you. Some examples I am writing. Examples. Tell whether these are polynomial in one variable. Okay, example is x plus 1 by x. First example is x plus 1 by x. Is it a polynomial in one variable? C. X can be written as x plus 1 by x. You can write in the previous number systems video. I have already told you about the properties. Okay, laws of exponents. X to the power minus 1 can be written as 1 by x. Understood? So 1 by x we can write x to the power minus 1. Here I have told you two properties here. One is when a polynomial, how we are going to know whether it is a polynomial in one variable? That means only one variable is present and the exponents in the variables. Exponent in the variable over the whole equation is whole numbers, are whole numbers. Is minus 1. Here what are the exponents? Here what are the exponents? 1 is 1, 1 is minus 1. Is not a whole number. Is not a whole number. So this expression a polynomial, you can say, or polynomial in this expression or in one variable. Expression is not, this expression is not polynomial in one variable, because here what exponent, one of the exponent is negative, so it is not a whole number. Of the two conditions, one condition it is not matching. Similarly, second one is root x plus 3. Root x plus 3 you can same in the previous class. You have to go and check number systems video. Okay, root x can be written x to the power 1 by 2 plus 3. Understood? Now exponents. Exponents are what? Exponents used are 3 can be written x to the power 0. So exponents can be written as 1 by 2 is one of the exponents and 0 is one of the exponents. So 1 by 2 not a whole number. this expression is not a polynomial, in one variable. Understood? Because one of the exponents is not a whole number, it is a rational number. Understood? Third question, same way. Cube root of y plus y square. Again cube root, this was square root. Cube root can be written as y to the power 1 by 3 plus y square. Again same exponents. Here one of the exponents is 1 by 3. Here one of the exponent is 1 by 3 and the other is 2. 2 is a whole number, but 1 by 3 not a whole number. So again this expression is not a polynomial in one variable. Understood? Another expression I am writing, 4x square plus 2y plus z. Okay, is this a polynomial in one variable? No, this is not a polynomial in one variable because it contains more than one variable, that is x, y and z. Understood? In those cases the exponents were not whole numbers, but here in this expression there is more than one variable. X also is there, y is also there, z is also there. There is more than one variable. That is why this is not a polynomial in one variables. Okay. One more important point is polynomials needs to have finite terms. It cannot have infinite terms. Okay, it needs to have finite terms. This is one more point. Okay, needs to have finite term. Now we classify polynomials based on the number of terms it has. Okay, first is monomials. These are what? Polynomials. Monomials means mono means one. Okay, polynomials with only one term. We are classifying polynomials. Okay, this first part is only about the types of polynomials and everything. Okay, so we are classifying polynomials here based on the number of terms. Monomials means polynomials with only one term. Okay, some of the examples are px equals to 2x. Okay, qx is 5x cube, rx is 2, su equals to u4. See, only one term is there. 2x, 5x, 2, only one algebraic expression you can see. Only one term is there. Okay, only one term in the polynomial. So it's a monomial. Understood? Second one is binomial. Similarly, binomial. Bi means what? 2. So this is polynomials with only two terms. Examples: if the polynomial contains two terms only, those are binomials. Px equals to x plus 1, Similarly, qx equals to x square minus x ry y to the power 9 plus 1 tu u to the power 15 minus u square. See, here only two terms are there. Here also two terms. Okay, here also two terms. Only two terms in the polynomial. So it's a what it is called binomial. Understood? Only two terms, not more than two. Only two terms are present. So it is a polynomial. Binomial, sorry. Third is a trinomial. Tri means what? Three. Okay. Polynomial with only three terms. Okay, polynomial with only three terms. What can be examples are? Px equals to x square plus x plus 1. Okay, qx equals to root 2 plus x minus x square. Ru equals to u plus u square minus 2. Ty equals to y square plus y plus 5. So all these are having three terms. X square is there one term, x is one term, 1 is one term, root 2 one term, x square one term. Three terms are there. Everywhere three terms are there. If it contains three terms, it is what it is called. It is called a trinomial. Because it contains only three terms. Understood? This is trinomial. Now here what you are going to learn? We are going to learn about degree. We are going to learn about degree of a polynomial. Degree of polynomial. What is called a degree? Okay. What is degree? Degree is actually the highest power. Or you can say the highest exponent of the variable in the polynomial. Okay. It is the highest power, or you can say exponent, highest power or exponent of the variable in a polynomial. Degree of the polynomial is what? Highest power or exponent of the variable in a polynomial. It means, this thing means what? It is maximum of all the powers or exponents of variables. What is this maximum? Means all the exponents you combine. You see, it can be, I am giving you an example. See, this is 3x to the power 7 minus 4x to the power 6 plus x plus 9. This is 7. Understood? So what? Here all the exponents we combine and we find the maximum of it. Maximum of what? First one is 7. This expression here the exponent is 6. Here what the exponent is 1. Here the exponent is what? X to the power 0, it means it is 0. Maximum of 7, 6, 1, 0. What is the maximum of this? This is the 7. So degree of the polynomial here, polynomial is 7. You have to find the maximum in the power of the variable. Maximum power. Okay, in the variables. That is degree. Okay, one more example. 5y to the power 6 minus 4y square minus 6. So it is maximum of what? I have to find the maximum of, this is 6, this is 2, and this is 0. Maximum of 6 and 2 and 0 is 6. So degree of the polynomial equals to what? 6. Understood? Sorry. The degree, this is an important point. the degree of a non-constant, sorry, not non-constant, non-zero constant. Degree of a non-zero constant polynomial is 0. Degree of a non-constant polynomial is 0. This is self-explanatory, I can say. Non-zero constant polynomial means I've already told you integers are constant. Integers are constant polynomials. Are constant polynomials. Okay, integers are constant polynomials. Example 2, 5, minus 15, etc. Okay, if you write 2, 2 can be written as 2 into 1. This again can be written as 2 into x to the power 0. See, x to the power 0, this whole thing 2 into it, this can be written as 2x to the power 0. So in this expression the maximum power is what? 0 only, no? So the degree is 0. Getting it? The degree of a non-zero constant polynomial is 0. You understood? Now one example, first example of this chapter in NCERT, it is given. Find the degree of each of the polynomials given below. Okay, first question is x to the power 5 minus x to the power 4 plus 3. So we know the, see, you have to write what is degree of the in exam. You have to write what is degree of the polynomial, then we have to write the value. So I am directly writing the value because I have already told you the definition of degree. So again I am not going to write. So this is maximum of what? Maximum of the power first exponent is 5. Second exponent is 4. Third exponent you can write it as 0. Okay, 5, 4, 0. So the maximum of this is 5. So degree equals to what? Degree is coming as maximum is 5, so degree is also 5. Second question is given as 2 minus y square minus y cube plus 2 into y to the power 8. Okay, same thing, you write maximum of, from here you can say y to the power 0, you can write, so 0, then this is 2, then this is 3, then this is 8. The maximum of 2, 3, 8. 0, 2, 3, 8 is maximum of this is 8. So degree is what? Degree of this expression is what? Degree of this expression is 8. Okay. Third question is 2. We have solved. This is a constant. What is this? What it is called? It is a constant polynomial. Understood? This is a constant polynomial. This 2 can be written as 2 into 1. This can be written as 2 into x to the power 0. So maximum of 0 is 0. So degree is what? We have already solved maximum. Maximum of exponents is degree. So degree is also 0. Understood? Now linear, the term classification based on degree. This is classification of polynomial based on degree. Understood? First is linear polynomial. Linear polynomial if degree of polynomial is 1. Linear polynomial means degree of the polynomial is 1. Okay. If the degree of the polynomial is 1, see, linear polynomials, why I will tell you also. Linear polynomials cannot have more than, I can write. So linear polynomials cannot have more than 2 terms. Okay. And one thing is general form of linear polynomial equals to ax plus b. Okay. See, three things I have written. Linear polynomial. See, if the polynomial has its degree as 1, it is called linear polynomial. And general form of the linear polynomial, degree is 1 means only variables highest. That means variables highest power can be 1. So maximum you can write it as once only. Okay, x variable. How many times x you write? 4x, 5x, 10x. See, if you write 4x plus 5x plus 6x, okay, and so on plus 10. So you have to add these x, no? Then the resultant, suppose it is coming in 100x plus 10 it is coming. So this is what? Ax plus b. You are getting it? Because of this, see, only degree 1 can be there. If degree 1 is there, no, that means x to the power only 1 can be there, and one another x to the power 0 can be there. If linear polynomial is there, that means only x to the power 1 and x to the power 0 can be there. Hence, only two terms. X to the power 1 is one term, x to the power 0 is two terms. Means so is only two terms can be possible. There cannot be more than two terms in linear polynomials. Okay. Examples I am writing px equals to 4x plus 5, qy equals to 2y. Okay, and one more I am writing rt equals to t plus 2. These are examples. Okay, see here two terms are there, here only one term is there, but the power I am said that cannot have more than, it can have only one term also. Okay, but it cannot have more than two terms. Only one, 2 to the power y. Here 4x plus 5, two terms are there, and degree is 1. You are getting it? See here a, b are constants. A and b are constants, and a cannot be equals to 0. If a becomes 0, now only b part is remaining. You are getting it? So a can never be 0. If a becomes 0, only b part is remaining. Then it is not a means linear polynomial. Okay. Here only x to the power 0 part is remaining. X to the power 1 part is 0. So a can never be 0, and these a and b are constants. That is linear polynomial. Understood? Second is quadratic polynomial. Quadratic polynomial. Polynomial having degree. Polynomial having degree what? Having degree 2. Okay. General form I am writing first. General form is ax square plus bx plus c. Okay. Where a, b, c are what? A, b, c are constants. Understood? And a cannot be equals to 0. If a becomes 0, then x square term is 0. So it will become what? Linear polynomial it will become. If you write, if a is 0, then this x square term will vanish. It will become bx plus c. So it will become a linear polynomial. So a can never be 0, and a, b, c are constants. Okay. Similar to that linear polynomial, we wrote that linear polynomials cannot have more than two terms. So quadratic polynomials cannot have more than three terms. Why? See, one is the term of x square, one is the term of x1, one is the term of x0. Maximum three terms can be present. That is x square, x1, x0. Those are the three terms that can be present. Okay. Examples of it are, see, px 5 minus x square. Okay, one more example I am writing only, 4y plus 5y square. Okay, these are containing two terms. These all are containing. One more example I am writing, qy equals to 6 minus y square. This is 1. This is containing three terms, this is containing two terms, but the degree is 2 here. You are getting it? Now, third is cubic polynomial. Cubic polynomial. Understood? Third is cubic polynomial. Okay. Here cubic polynomial means what? Polynomial having degree, cube means degree 3. What is the general form? General form is ax cube plus bx square plus cx plus d. See, ax cube term is there, then x square term will be coming, then cx term will be coming, then x to the power 0 term will come. Okay, this is a general form. And where what? A, B, C, D word are what? Constants, and A cannot be equals to 0. Okay, similarly cubic polynomials cannot have more than 4 terms. How? See, x cube term is 1, x square term is 1, x to the power 1 term is 1, and x to the power 0 term is 1. So max 4 terms it can have, not more than 4 terms. Okay, so those are cubic polynomials. Understood? Now see, in this degree based, one is linear, means degree is 1, quadratic degree is 2, cubic polynomial degree is 3. Then we can generalize it. In general, a degree polynomial, a polynomial in one variable, of degree n is as follows. Okay, in general form, a polynomial in one variable of degree n, okay, is as follows: a to the power n x to the power n plus a n minus 1 x to the power n minus 1. See, this a n means the nth coefficient. A n means nth coefficient. Okay, a n minus 1 means n minus 1th coefficient. Understood? Similarly, a1 means first coefficient. You getting it? Nth coefficient means coefficient related to x to the power n. Okay, so this will continue till what? a1 x to the power 1 plus a0. Okay, so this is a polynomial in one variable of degree n. This is the general form: an x to the power n plus an minus 1 x to the power n minus 1, where we can write an minus 1, a1, a0 are what? Are constants, and an cannot be equals to 0. This is nth degree, no? Nth degree, and general form of nth degree is this. Of nth degree polynomial in one variable is this. Okay, an x to the power n. See here what we are doing. This can be written as cube in general form. Cubic one can be written as what? How? a3 x to the power cube, a2 x to the power square, a1 x to the power 1 plus a0. This is the general form. I was writing ABCD. After 26 there will be no ABCD. Okay, so this is the better form: a3 x to the power 3, means a3 is the coefficient related to coefficient of x3 actually, not related to or something. Coefficient of x3 and so on. Understood? So this is the general form of this. Now if I write if, okay, if we make every constants, all these constants an minus 1, okay, and so on, a1 a0, if we are going to make it equals to 0, okay, all the values of the constants are 0, okay, all constants are 0, we get a 0 polynomial. Okay, I told you earlier 0 is a 0 polynomial. If I make all the constants as 0, this nth degree is polynomial you will get 0. If I make every constant here 0, you are going to get the resultant as 0. Okay, going to get the, and I have already told you that 0 is a 0 polynomial. Okay, so from here also you can check that 0 is a 0 polynomial. The important point is the degree of a 0 polynomial, is not defined. Understood? The degree of a 0 polynomial is not 0. The degree of a 0 polynomial is not defined. Okay. Then we can have polynomials in more than one variable. Polynomials in, we are only going to see some of the examples. Px comma y. Okay, this will be x square plus y. One polynomial can be, this is there to have two variables. In this they have two variables, x comma y, and this is q, x comma y comma z. Okay, this one x square plus y to the power 4 plus z. Here this is having three variables. Okay, so the polynomials are there. We are only studying about polynomial in one variable, not the polynomials in two variables or something. Okay, in this section. So this is the end of the first section. We'll go for exercises now. The first exercise. Okay, I will speed up everything because I've already told you about the process and everything of these questions. Okay, which of the following, okay, we have already done some of the examples. Which of the following expressions are polynomials in one variable and which are not, okay, state your reasons. Also they are asking, state reasons for your answer. I will only write the reasons in brief. You have to explain everything. Okay, this and that I have taught you in the theory section. So the first question is 4x square minus 3x plus 7. So you have to match, in every question you have to match the two conditions. You have to write it. In exam you have to write the two conditions, that for the polynomial to be a polynomial in one variable, we have to have only one variable in the polynomial, and the exponents or powers of the variables should be a whole number. Okay, those were the two conditions. Here you see, here only one variable x is present. Only, see, this I am writing as first 4x square minus 3x plus 7x to the power 0. This is 1, x to the power 1. Okay, only one variable x is present. First condition is okay. Second is exponents. Check the exponents. Exponents are 2, 1 is 2, 1 is 1, 1 is 0. 2, 1 and 0. All are whole numbers. Okay, so it is a polynomial in one variable. Okay, you can also write the degree here. Degree is what? Maximum of 210 is 2, so degree is 2. Understood? Second question, it has asked y square plus root 2. You write this y square plus root 2 can be written y to the power 0. See, one variable present. One variable present. Okay, second, exponents. Exponents are what? 1 is 2, 1 is 0. Exponents 2, 0. All are whole numbers. All are whole numbers. So, polynomial in one variable. And degree is? Degree, how much? What is the degree? Maximum of 2 and 0 is 2. So, degree is 2. Understood? Degree is not asked. I am only writing for you. The third question. Third is 3 root t plus t root 2. See, this one can be written as I have already told in the previous section. Root 2 can be written as 2 to the power 1 by 2. Plus this is t to the power 1 into root 2. Okay. So, first condition is what? One variable present. It's okay. Okay. It's okay. Second condition is exponents. Exponents is what? 1 is 1 by 2. Exponents are 1 and 1 by 2. Not a whole number. 1 by 2, not a whole number. So this one, not a polynomial in one variable. You are getting it? One of the exponent is not a whole number. 1 by 2 is not a whole number. So it is not a polynomial in one variable. Okay. Fourth question is given by y plus 2 by y it is given. See, 1 by y can be written as y to the power minus 1. I have already told you. This is 2 into y to the power minus 1. This is y to the power 1. This is 2 into y to the power minus 1. One variable present. One variable present. This part is okay. Second part, exponents. Exponents are what? One is 1, one is minus 1. Exponents are 1 and minus 1. This is not 1. Minus 1 is not a whole number. This is minus 1 is not a whole number. So this is it. Not a polynomial in one variable. We are getting it though. We have done 3-4 examples before in the theory section. Why? Though two conditions you have to match. Okay. Fifth question. Fifth question is x to the power 10 plus y to the power 3 plus t to the power 50. Here the first condition itself is not met. One variable present is wrong. Three variables x, y and t are present. So not a polynomial. So not a polynomial in one variable. You are getting it? X, y and t are present. So not a polynomial in one variable. Okay. Now second question. Second question is write the coefficient of x square in each of the following. Okay. 2 plus x square plus x. Okay. This can be, see, it is not required, but I am writing it also. 2 into x to the power 0. Here x square, it is 1 into x square plus x. So whatever is multiplied, whatever constant is multiplied, coefficient of x square, what I am writing? Coefficient of x square, constant multiplied to x square is coefficient of x square. So constant is multiplied what? Is 1. So coefficient of x square equals to 1. See, this thing I will not write in every question now. Coefficient of x square means constant multiplied to x square. If coefficient of x was told to find out, it will be constant multiplied to the term x. Okay, constant if it had been told to find the coefficient of x to the power 0, so the only these two would be the answer. You are getting it? So I will not write every time. Second question, similarly it is given 2 minus x square plus x to the power 3. Okay, this can be written as what? 2 plus minus 1 into x square plus x to the power 3. So minus 1 is multiplied to x square actually. Okay, so coefficient of x square equals to minus 1 is the answer, not 1. This is minus 1. Okay, all the expressions should be plus. Third question is pi by 2 x square plus x. See, this is pi by 2. This means pi by 2 into x square plus x. So pi by 2 is multiplied. So coefficient of x square, answer equals to pi by 2. Understood? One more question is there. Fourth question is root 2 x minus 1. See here, what is x square term is not present. That means the coefficient is 0. X value will not be 0. Okay, because x is present here, x value will not be 0. That means the coefficient term is 0. So we can write 0 into x square plus root 2x. Okay, minus 1. Now with x square what is multiplied? 0 is multiplied. So coefficient of x square equals to what? 0. Understood? The third question is written, give an example each of a binomial of degree 35 and I do not have space actually, and a monomial of degree 100. Okay, so see, read the question. I am telling you again. Give an example each of binomial degree 35. See, first, what is binomial? Binomial means only two terms. Okay, next is given degree should be 35. So you have to use any two terms, and one of the terms variable should be 30. Variable's power should be 35 because degree is 35. Okay, so example, you can take 4 x to the power 35. Any constant can be there. Okay, x to the power 35 plus you can take x to the power 34 also. I am taking only 2. Getting it? This can be an example. 1 x to the power 35 should be present because it is binomial, means two terms should be there, and degree 35 means 1 x to the power 5 should be there. And it said a monomial is also said. Monomial means only what? Only one term. And degree he has said as 100, I think. Okay, degree what? Degree is 100. Means one term and the degree should be 100. That means 1 x to the power 100 term should be there. X to the power 100. Okay, 1 x to the power, because degree is 100. That means 1 x to the power 100 term should be there. And you can put any, suppose 9. You can put any constant. You can put 0, 1 also, not 0, 1 also. 900, whatever you want, you can put. Yeah, okay. So this is one example. The fourth question is write the degree of each of the following polynomials. See, again, examples we have done about it, the finding the degree. Okay, what is degree? First I'm going to write here, what is degree? Degree is what? Highest power or exponent of the variable in the polynomial. Okay, in the polynomial, highest power or exponent, you can say that in the polynomial. The first question is what? 5x cube plus 4x square plus 7x. So highest power. What are the powers? Powers means I was writing what? How powers you have to write? Maximum of those powers. See, maximum of those powers are, one power is 3, one power is 2, one power is what? 1. Maximum of 3 to 1 is 3. So degree equals to what? Degree equals to 3. You have to write this statement in every question in exam. Okay. Second question, 4 minus y square. Okay, this can be written as 4y to the power 0 minus y square. Are you getting it? Now maximum of what? 1 is 0, 1 is 2. That is 2. So degree equals to what? Degree equals to 2. Now third question. Third question is given as 5t minus root 7. 5t minus root 7 can be written as what? 5t minus root 7. This is t to the power 1. This is t to the power 0. If it is not 1, means t to the power 0. So maximum of what? Maximum of 1, maximum of 0 equals to what? Maximum of 1 and 0 is 1. So degree equals to 1. Fourth question. Only 3 is there. This is a constant polynomial. Constant polynomial means we know degree is 0. Okay, how? See, 3 can be written as 3x to the power 0. And maximum of only 0 is 0. So degree equals to what? 0. Understood? And now I am moving to the last question of the exercise. Okay, because the video has become too long also. So classify the following as linear. Okay, linear, quadratic and cubic polynomials. Okay, before classification, again I am going to make you revise what is linear. Linear means degree of polynomial equals to 1. Quadratic means what? Degree of polynomial equals to 2. Form is ax plus b. Here form is ax square plus bx plus c. Okay, now cubic degree of polynomial if is 3, degree of the polynomial is 3, it is called cubic. And form is ax cube plus bx square plus cx plus d. Getting it? This is the form. Linear, degree of the polynomial is 1. The degree of the polynomial is 2. To quadratic, if it is 3, it is cubic. Okay, so we have to find the degrees in this question actually. So the first question that is given is x square plus x. Okay, so this can be written as what? X square plus x to the power 1. So it is maximum of 2 and 1 is 2. So degree is 2. So quadratic. Okay, quadratic. So every time I'm not going to write this thing. You are better understood. I've already done so many examples. So directly I will write the degree. And so it is quadratic or linear. Okay, this maximum and everything I have told you. Degree. This is 4 questions in the examples and also I have done. So I've told you how to find the degree. So directly I will write the degree. Now x minus x cube. See, the x minus x to the power 1 minus x cube. So degree is what? 3. Degree is 3 because the highest power is 3. Degree equals to 3. That means it is cubic. Understood? This is cubic because this is 1. This is 1. Max of 1, 3 is 3. Understood? The third question is y plus y square plus 4. Okay, so this one is y to the power 1 plus y to the power 4 2 plus 4 into y to the power 0. So it is maximum of what? First is 1, then 2, then 0. 1, 2 and 0 maximum 1. So degree is 2. This is quadratic. Okay. Fourth question. 1 plus x. 1 plus x can be written as what? X to the power 0 plus x you can write to the power 1. So this is maximum of what? 0 and 1 or is 1. So degree equals to 1. If degree is 1, this is linear. Understood? Fifth question. 3t it is given. If 3t, same thing, 3t means this is to the power 1. If to the power only one term is there, degree is 1. If degree is 1, this is what? This is linear. Sixth question is r square. It is r, let me write it again, r square. Okay, r square means only 2 is there. So degree is what? 2. So it is quadratic. Understood? The seventh question is 7x to the power 3. Okay, only 3 is there. So degree is 3. If degree is 3, this is cubic. Okay. So with this we have finished the chapter. So not chapter, the first section of the chapter polynomial. Okay. So I have discussed many things. Though what the classifications of polynomials, what is algebraic expression, what is polynomial. Okay. All those terms I have discussed, and I have solved the examples and exercise also. So in this part, if you have any doubt or if any other question also you have any doubt, you write it in the comment section. I will answer those, try to solve those answer questions in the comment section. Okay, and if you have any difficulty and if you don't like anything about this video, like if I'm going too fast or too slow, you can comment it in the comment section. In the next videos I will try to rectify the issues. Okay, if you don't comment, then I cannot know what is the feedback. So it is better if you comment. If you don't like anything also, you comment. I will rectify the issues in the coming videos. And if you like something, then also you write in the comment section and you like the video. And if you have any friends, you can share the videos with them so they can also benefit, okay, from these classes. Okay, so till the next lecture, stay safe and thank you for listening.